projections and their presentation. Let us consider point A. This is our direction 1. If I will look towards point A from this direction, then point A will appear to be on VP at this location. Or if I will put a beam of light on point A from this direction, then point A will have its shadow lying on VP at this location. In other words, we will feel that point A lie on VP at this location. This point on VP is known as projection of point A on VP. It is known as elevation. Similarly, if I will look towards point A from direction 2, then point A will appear to be on HP at this location. It is known as projection of point A on HP, that is plan. Plan and elevation, these are two projections. In conventional way, plan is also known as top view, while elevation is known as front view. Let us see here how to name the projections. This is again point A. This is projection of point A on VP, that is elevation or front view of A, and now onwards we are going to name it as A dash. On other hand, this is a projection of point A on HP, that is plan or top view, and we will name it as small letter A. Plan and elevation are two projections. In simple words, they are two views. In future, we are going to use these two views to convey the geometrical features of any object. So, we will draw these views, that is plan and elevation, for every object. Object may be a nut and bolt, or it may be a chair or a building or a car. Plan and elevation are two projections. In simple words, they are two views. In future, we are going to obtain these views for different objects. For example, it may be a nut or bolt, or a chair, or a building, or maybe a car. These views are used to convey the geometrical features of the object. The essential task of this language, that is engineering graphics, is to assure that there won't be any confusion or misunderstanding in the communication process. Hence, we must follow the way of presenting these views decided by this language. Again, let us consider point A, and here is elevation of A and plan of A. To present both the views on a single plane, that is, say our plane of paper, what we will do is we will rotate HP. HP is rotated through 90 degrees in clockwise sense. Hence, in final position, HP will coincide with VP. Plan of A lie on HP, and hence it will also move along with HP, and finally it will take position here. Now, in the final position towards this system, if we will look from this direction, then you can imagine XY line will appear as a horizontal line. Both projections A dash and A will be on a vertical line. A dash, that is elevation, will be at this location, that is 10 mm above XY line, and plan of A will be at this location, that is 20 mm below XY line. Thus, after getting the projections, we will produce them in this way. Now let us apply the same procedure to the points in various quadrants. Look here, this is point B. It is 16 mm above HP and 10 mm behind VP. Here we get elevation of B, that is B dash, and here we get plan of B, that is B. After rotating HP through 90 degree in clockwise sense, the plan will move and finally it will take this position. Now, looking in this direction, we can say that both these views, plan and elevation, will lie at these two locations, that is above XY line. Specifically, plan is 10 mm above XY line, while elevation is 16 mm above XY line. This is a point C. It is in third quadrant. Specifically 10 mm below HP and 20 mm behind VP. Again, elevation C dash and plan C. Along with HP, point C, that is plan, will move and finally it will be at this position. Thus, both the projections C and C dash will appear on a vertical line. C will be here and C dash, that is elevation, will be here. Again, point D, it is in fourth quadrant. Specifically 20 mm below HP, 10 mm behind VP. Plan of D, elevation of D. After rotating HP, D will move to this location and finally here it will appear on a vertical line. Plan will be 10 mm below XY line and elevation will be 20 mm below XY line. Now, before proceeding further, again I will introduce you few new terms. You should remember them well. Look here, a vertical line on which both views, plan and elevation, lie. It is known as projector. Thus, plan and elevation of A will lie on projector of A. Plan and elevation of D will lie on projector of D, and so on. Similarly, a line passing through a particular projection while parallel to XY is known as locus. Thus, you can see here this horizontal line is known as locus of D dash. Finally, consider point D. It is in fourth quadrant. Specifically 20 mm below HP and 10 mm in front of VP. The projections, plan is here and elevation is at this location. After rotating HP, plan will move and finally will take this position. On our drawing paper, we will show plan and elevation at these locations, that is plan is 10 mm below XY line and elevation is 20 mm below XY line. Thus, on left side, what we can see, it is orthographic system of planes, while on right hand side, what we can see, they are the orthographic projections of a point. Before proceeding, have you noticed few new terms? Let us take a look. The first term, projector. A vertical line, that is line perpendicular to XY line on which both views, plan and elevation, lie, is known as projector. Thus, plan and elevation of any point will always lie on its projector. Second term is locus. A horizontal line or line parallel to XY line and passing through a particular view is known as locus. Thus, a line passing through A dash we will call it as locus of elevation of A. Similarly, line passing through A, we will call it as locus of plan of A.